Hello, and welcome back to Technology Now, a weekly show from Hewlett Packard Enterprise where we take what's happening in the world and explore how it's changing the way organizations are using technology. We're your hosts, Aubrey Lovell
and Michael Bird. So, in this episode, we are looking at a pressing issue that goes well beyond the tech world: sustainability and our networking infrastructure. Now, that doesn't mean sustainability within the network itself, although that's certainly part of it. This is about making networking part of our sustainable solutions. In this episode, we'll be asking how networking and sustainability can go hand in hand. We'll be asking just how much of a difference to our energy usage connected infrastructure can make, and we'll be asking whether networking can ever truly be green.
So, if you're the kind of person who needs to know why what's going on in the world matters to your organization, this podcast is for you. And if you haven't yet, which we hope you have, subscribe to your podcast app of choice so you don't miss out. All right, Michael, let's get into it. So, there's a few elements to sustainable networking. First, there's the network itself. According to statistics from the UN, which we've linked to in the show notes, approximately 62 million tons of e-waste was produced in 2022. And that's set to rise roughly 80 million tons by 2030. Meanwhile, just 1% of the world's rare earth mineral demand is met through recycling. So clearly, the thousands of switches and routers and miles of cabling involved in an enterprise-level network are a prime candidate for reducing that waste through refurbishment or recycling. We've got an episode on how HPE deals with that piece of the puzzle, which we've linked to in the show notes.
So, we can make our tech greener, but we can also use our tech in more green ways. For example, in so-called smart buildings. These are IoT networks which eke every last bit of energy-saving opportunity from our facilities and can save a lot of money in the process. To tell us more, I recently interviewed John Howell. He's the Smart Spaces and IoT lead for Europe, Africa, and the Middle East at HPE Aruba Networking. John, welcome to the show. Thank you so much for joining us.
Thanks for having me.
So, first question, what is sustainable networking?
There's three elements to sustainable networking. You've got the sustainability element of itself. So how do we reduce power in the products? But then there's the second piece, which is using the products to attach to sensors to make a building more sustainable, which I can explain. And then there's a third element, which is aggregating all of that data together via our network and then pushing it into your smart building software. So take, for example, you're in a school, the heating's too high, which is one thing we're dealing with, and the building needs to react and open the window. So the network realizes through the sensors that the classroom is too hot. It goes back to the building management platform and goes, open a window.
Got it.
And that's the basic elements of sustainable networking.
Talk us through some of the factors that can make a networking solution more wasteful or less efficient than it perhaps needs to be. So I guess covering off things like hardware, energy usage, e-waste, cabling.
That's where I come in, actually. So I've been doing this for about 8 years because networking generates a lot of wasted power. So you imagine you take a large university. We're working on 4 at the moment, all saying their network is on all day, all night. You've got no students in there, 2 a.m. in the morning, all the lights are on in the labs across the whole campus. So that network is drawing 21 watts of power per access point, and there could be 9,000 of these things sitting there. So the first thing we're doing is we're using this AI engine to say, the campus is empty, all the kids are on holiday, let's turn it all off.
Yeah.
That just alone can save €300 a year per 100 access points in energy. So that's one thing by using this AI engine.
Yeah.
And that's simple. Look across the campus. Is anyone using the Wi-Fi? Turn it off like you would at home with a TV. Yeah. And then the second piece is switches, networking switches you see in cupboards. They generate a lot of heat, generate a lot of energy. So most of the time in smart buildings, big universities, you name it, building like this, you've got thousands of kilometers of cable to power things like cameras and sensors and all these things. So what I'm doing is ripping it all out. So, which is a strange thing to say when you work for a networking vendor. But what I'm doing is I'm working on a college project at the moment, to give you an example. They wanted 750 wired sensors. That's the sort of thing you'll look up here and you'll see smoke detectors, lighting, CO2, all those things, indoor air quality. And I went into the room with Aruba, which was interesting, our sales team. And I said, tell you what, don't buy 37 switches. Take 5,800 kilometers of cable out of the building, which saves a massive amount of rare resource with copper.
Yeah.
Use Wi-Fi.
And is Wi-Fi reliable enough? Because, I mean, I've always been taught if you can wire it in, always wire it in.
Yeah.
Wireless should be almost as a backup. You know, particularly if it's a critical system or a sensor, always wire it.
Yep.
So is that school of thought changing?
So what we're using in a few examples is we're using energy harvesting technology that has no power, no batteries, nothing in it. They last 15 years, 20 years. We don't build those, by the way. They're part of our ecosystem. Now, because they're energy harvesting, there's no risk of them dying with power failure.
Sure.
So the sensors are always reporting back. But then you've got the issue of the Wi-Fi. So what we have is we have this redundant IoT radio. So the sensors in the building aren't using the Wi-Fi. They're using a sub-gigahertz network of its own that sticks into the back of the access point. And the sensors will capture data even if the Wi-Fi trips, goes out, reboots. They'll still be pulling in that data and then packaging it back.
Wow.
So it's an amazing solution because you actually can walk into a customer and say, we won't use any cabling, we won't use any power, there's no batteries. So batteries are a big sustainability issue.
Yeah.
If you take very large healthcare trusts in the UK that we all know, in their demands for sustainable networking, it says you cannot use batteries. They're full of lithium, cobalt. They take one person a year to change the batteries per hospital.
Yeah.
So I go in and say no batteries, no power, no cables, much less switching, which is much less power, with the AI networking turning all the network off, and you can save 28, 35% in energy costs.
That's quite revolutionary. Rip out the cabling and do everything wirelessly.
It's not great when you work for a networking vendor, but it's the way the market's going. If you look at the US, they're banning battery-based sensors.
Yeah.
In the UK, it's happening a lot. But the biggest driver of it is actually these new EU energy directives. So I've just done a big bank in Europe, and the whole reason they bought our Aruba platform with these energy harvesting sensors was there's a new regulation in France coming in January called BACS, Building Automation Control Systems. So by law, every commercial building in France has to report on its CO2 consumption and how it's trying to save energy by law. So all of a sudden, you've got all of our customers going, we need to use the network because we need to know CO2, energy, air quality, occupancy, space optimization. So that's why I'm busy.
So sustainable networking, is it something that customers are raising to you as a key factor, or is it something that feels like you're still driving, you're still speaking to customers about? Is it sort of push or is it pull?
For the last 5 years, I think I was laughed at.
Okay.
Definitely laughed at. Whether it's not really happening, the market's in a peak, when it's accelerating. But in the last 2 years, I'm booked solidly for 3-4 months in advance, just seeing customers about sustainable networking.
Wow, it's an honour to have you here then.
Oh, no, it's fine. But it's things like universities. I met the head of climate change at a big university, and I didn't realise that role existed.
Yeah.
So now there's director of climate change, head of climate change, technology climate change. And they sat me in a room and said, we need to know if the lights are on, how occupied our rooms are, the indoor air quality, CO2, flood detection for every single room in this campus. And we have 300 buildings.
Yeah.
And we need to know it in the next 2 years. And then I went to the next one. And I think it's all around, since things have happened geopolitically, the cost of energy. She explained to me their university campus is spending €2 million a month on energy.
That is a significant amount of money, isn't it?
So if you take one of these energy harvesting radiator valves, so at home when you turn it to 5,
TRVs, yeah.
We've got an energy harvesting TRV. You put it in that campus and it says it's gone above 21 degrees. It just turns itself down using the ambient temperature to power itself.
Wow, okay. Because of course, building sensors have been around for years, but I suppose what we're talking about here is making sure those sensors aren't adding to the issue of using lots of power, using lots of cabling, making things more complicated. Because I have a smart home, and I say I have a smart home. Often it's not very smart. Often it just breaks because stuff doesn't talk to each other, and different radio frequencies and different protocols, and it sort of never really works. So I guess what we're talking about is trying to alleviate all of those issues whilst also being able to report on what's actually happening within your building.
But then you've got the bigger issue, which is what we're doing now at Aruba, is IoT security.
Okay.
We're launching next year a IoT behavior engine. So that will look at the sensors and go, where is this data going?
Yeah.
And you can actually, the AI will choose how it behaves, how it's profiled, if it's visible, how it's enforced. So that it's security and trying to get all those protocols together. So you can see that it needs to simplify, because a lot of people say what you say. I'm running 3 different systems. The lights don't work at 11 o'clock.
Yeah.
And you imagine doing that in a building like this.
I mean, the building that we're stood in at the moment has probably got, in my eye, like, I don't know, 1,000 lights.
Yeah.
You know, just imagine each of those had sensors, and having to, I don't know, do a reset like I've had to do before my lights. I mean, it would never happen. It's just not practical, is it? So,
and that's why this energy harvesting technology is fascinating for companies like this, because you'd need a very big crane to go and change that sensor up there. So if it lasts forever, it's a lot easier.
Perfect. Yeah. No batteries to change. No, that is perfect.
Thanks, Michael and John. There are some amazing insights in there.
Right. Well, now it is time for Today I Learned, the part of the show where we take a look at something happening in the world that we think you should know about. Aubrey, what do you have this week?
Ooh, it's a very exciting one this week. A team of researchers from a university in Georgia in the US have developed what they believe could be a universal flu vaccine, ending the need for yearly shots and saving hundreds of thousands of lives every year. Very interesting. So at the moment, flu shots only tackle 1 or 2 similar strains of influenza every year. In bad years, the flu vaccine can only provide 10% protection, resulting in upwards of 650,000 deaths globally. That's according to international research published in the Lancet journal, which we've linked to in the show notes. This time, the team tried a different approach. Writing in the American Society for Microbiology's M-Sphere journal, the team noted that instead of tackling 1 or 2 strains, they used machine learning and AI-based comparison to look at key components of different flu vaccines. Then, they compared them to various known strains. Essentially, they used detailed simulations to pick and choose the most promising features of a vaccine. By compiling a single vaccine which overcame the different defenses and features of various viruses, they were able to come up with one dose which, in mice, could cure multiple instances of very different influenza strains. A catch-all flu vaccine could save millions of lives and billions of dollars every year. It's a long way off going into production, but awesome nonetheless.
Yeah, that is really awesome. Thank you, Aubrey.
All right. Well, now, Michael, I think it's time to return to our interview with John Howell to talk about sustainable networking.
Is it possible to have a net zero networking solution? And if so, what might that look like?
That's a challenge. The 3 elements are recycling. Where's it coming from? What elements we're using? Then using energy harvesting technology, and then using AI to drop all that power down and get us close, but it will never be net zero. What we're doing at Aruba is we have a very good example is we've got a recycling plant in Erskine, and I think last year they recycled something like 29 million pounds in waste. So all the servers and the AP access points, things come back to there and get recycled. So I think you can get closer. If you use an AI engine to reduce the power completely when it's not being utilized, then it could.
Yeah.
But the biggest thing I'm working on now is, as you said, is trying to get the ROI proved so it can counter the draw of energy that the network's causing. The downside of working for a networking company is it does draw power.
Yes, this concept of switching networks off, your network off at various times, like I wouldn't ever profess to be a network engineer, but I've spent time around network engineers, and I know that might provide them a bit of nervousness, because I think always the thought is we just leave it switched on. Yeah. It is the backbone of your organization, your network. Switching it off and back on again. You have issues of booting it up. Will it actually boot back up again?
Yeah.
All of those challenges. So are people saying those sorts of things to you when you come up with that solution?
Yeah. So what it does is it doesn't turn it completely off. It goes into deep sleep, which draws like 3 watts instead of 21.
Okay.
Also, there's extra functionality now. So I was very worried about this because I was thinking, if this AI turns my network off and I've plugged all my sensors into this dongle that sits in the back, the whole building's going to die.
Yeah.
So I spoke to our product team and they said, no, you can isolate the IoT radios and make sure that doesn't switch off. And that draws tiny amounts of energy.
Yeah.
So that's one thing. But the second thing is, it will also listen You take a university, and they go, yeah, we're shut between this time. What if it's Freshers' Week and there's an open day on a Saturday? So it actually listens, and if devices start polling it, it will bring itself back online.
Oh, okay.
The other thing we're also doing as part of this isn't technically sustainable networking, but we've put GPS transmitters inside the access points. And what I'm doing is I'm working with large mapping companies that we all know to use occupancy data from that GPS to understand how the building's being used.
I see.
So facilities can then get rid of some buildings.
Yeah, okay.
It sounds a bit harsh. I'm working on a few big financial services customers at the moment. That one of them has 230 headquartered buildings, and they're using the network to understand that no one actually works in an office anymore. They're powering, cleaning, washing the floors of all these buildings.
Of course, yeah.
So their head of real estate said, we're going to get it down to 34.
Yeah.
They're just going to sell them all.
Yeah.
So that's another way. So we're using location-based services and GPS. We triangulate all that data from the access point with Bluetooth and other things. And then that presents a big dashboard that the customer then looks at and goes, right, our office in Zurich and our office in London, no one works on the 4th, 5th, 6th floors. We're going to rent them out to someone else.
Yeah. And these little incremental savings across multiple different facets of managing a building all add up, don't they?
Massively.
Yeah. So what's the future? If you're looking into 2025, 2026 and beyond, like, where is this technology going?
So there's some really interesting things happening now. There's a lot of new companies being invested in by the big tech companies that are focusing on AI-based energy management. And that's one thing I'm fascinated by, because as you quite rightly said, if you take a building like this full of sensors, we do the plumbing, the network, Ocean and people like that, they build the sensors, but then it all feeds back into a dashboard that's looking at a human.
Yeah.
And this poor guy or woman is a facilities manager for a big bank, and they look at it and go, wow, we've got this building, this problem, this one's too hot, there's too much CO2 in that one. These companies are building LLM-based AI energy management platforms, and they are amazing. I looked at one the other day, it's like 34% energy savings, because the AI, unlike a human, can look at every single sensor in the same time and say, this is the problem, these are the lights we have to turn off, this is the power we turn off, this is when the bathrooms need cleaning, and it does it.
Yeah.
And that's the future, definitely.
Thanks so much for bringing us that interview, Michael. It's been great to hear from John, and you can find more on the topics discussed in today's episode in the show notes. Okay, well, we're getting towards the end of the show, which means it's time for This Week in History, a look at monumental events in the world of business and technology, which has changed our lives. Okay, Michael, what do we have?
Well, the clue last week, Aubrey, was it's 1959, and this all-in-one was an all-star IT smash hit. Aubrey, did you have any ideas?
I don't. 1959 was a pretty long time ago, so wasn't around.
Well, it was the invention of the integrated circuit, the precursor to modern microchips, by American Jack S. Kilby. Now, the invention was a radical departure from efforts at the time to pack components closer together to miniaturize computers. Instead, his method involved all components of an electric circuit being formed on the surface of a relatively thin wafer, being shaped around each other to ensure isolation of all the components in the circuit. Now, the invention revolutionized computers, calculators, and other tech, and is still the basis for almost all the electronics we use today. Amazing. What's the clue for next week, Aubrey?
Well, the clue for next week is it's 1941, and this drug was a real cleanser. Ooh. Any ideas?
1941. Well, I know sort of penicillin is around that sort of time, but cleanser? No, probably not. So I don't know. No ideas. I'm going to go for penicillin, but I don't know if that's true.
I see where you're going with this.
Yeah.
Okay, we'll have to find out next time then. And that brings us to the end of Technology Now for this week. Thank you to our guest, John Howell, Smart Spaces and IoT lead for Europe, Africa, and the Middle East at HPE Aruba Networking. And to you, our listeners, as always, thank you so much for joining us.
Technology Now is hosted by Aubrey Lovell and myself, Michael Bird. And this episode was produced by Sam Datapolan with production support from Harry Morton, Zoe Anderson, Alicia Kempson-Taylor, Alison Paisley, and Alyssa Mitri.
Our social editorial team is Rebecca Wissinger, Judy Ann Goldman, Katie Guarino, and our social media designers are Alejandra Garcia and Ambar Maldonado.
Technology Now is a Lower Street production for Hewlett Packard Enterprise, and we'll see you at the same time, the same place next week.